Hi guys, and welcome back to another lesson of our Blender for Production series about 2D and 3D tracking inside of Blender. My name is Helge Maus from pixeltrain. Today we want to talk about the holy cow, about automatic feature detection or automatic tracking, which is available in other solutions, for example in SynthEyes, After Effects, in Foundry, Nuke or Fusion, but seems to be missing inside of Blender, which is not the case. We have something like an automatic tracking. I normally name it semi-automatic tracking. This tracking method is something I don't use too much in practice because most of the production shots are more complicated. You really have to make sure that you get a solid tracking result. But sometimes semi-automatic tracking is quite useful because sometimes you have a scene where we need a lot of trackers. For example, you want to have a reconstruction, a point cloud of a floor or something like that, which is not really even, and you don't want to go in and track, for example, 100 trackers. What I do then, I use this semi-automatic tracking techniques. I set 0 weight trackers and I get these trackers later as a result, and in reconstruction I can use them, for example, as a point cloud or something like that, or even as reference. But you also can try to solve your scenes with that. Like I've said, it's nothing bad with that, but you will see that we have to do some cleanup work. And this is exactly what this tutorial is about. I want to show you how to make this semi-automatic tracking inside of Blender, how to make your cleanup work, and how to get a solid shot out of that. For this, I decided that I want to give you this time a shot which is not so easy to work with. It's from my footage package, so if you are a Patreon of me, you can download it for free on my Patreon. If you want to support me, you can get it on Gumroad for a really small fee. But you can use also your own footage, so feel free of that. And you support me also if you subscribe and give me a thumbs up. I really appreciate that. But now gets into this shot here. Why is the shot not so easy? You've learned in all the lessons before how you think and see a shot as a match mover. Play this shot here and take a look into that. What do you see? Do you see problems? What are the challenges of this shot? So the first question you always have to ask is, do we have parallax in the shot? This is the most important thing. If I scrub now here through the shot, you will see that in the beginning we don't have much parallax. It's more like a nodal shot, and we have a lesson about nodal shots here in this series, so take a look here if you don't know what a nodal shot is. If you go now here a little bit farther, you then see, okay, now we have parallax. We have these houses here, we have these trees in the foreground and the background. And if I go now here over that, you will see that this tree here is moving to the right, this here is moving to the left. Here we have parallax in the shot, but we have not a lot. And we have seen that in the beginning we don't have much parallax, which means that we have to make sure later with our keyframes that we use a keyframe area where we really have parallax. So keep that in mind. Next thing is, okay, we have parallax. Do we have moving areas which are dangerous? So moving people, cars, flying birds, things like that. Foliage which is moving in the wind. We have a little bit of foliage here, but it seems wind still. We don't have people running around. That's nice. No cars here. But other things which are dangerous because they are moving are reflections, glittering water, windows, and things like that. So we have some windows, but not really obvious areas which a tracker maybe addresses. So yeah, reflections can be a problem, but not so much. Something which also makes problems in this low quality footage here, this is made with a mobile phone I think, can be compression artifacts. Because compression artifacts really often indicate for a tracker a little bit of contrast. For example, if you have here some clouds and then you have a compression artifact, a tracker maybe sees that as a feature. So keep that in mind. If you have a footage like that, that you look into that you don't get markers trackers there. Then the next thing we have here now is, let's analyze the parallax a little bit. So for this, I always search for 3 axes. Do we have 3 clear axes in the shot? Yeah, we have. We have features in this direction here. We can have features here and also here. So this axis is okay. We also have features here to the back and to the front. So for the floor, because we have all these here and we have parallax seen. So here we have enough features. But do we have an up and down axis? You see that my movement is really in one plane. I don't look up and don't look down and things like that. So we don't have much information here. We have here, and that's nice, some areas which are looking upwards. This can be here the trees, for example. But keep in mind that trees have really chaotic patterns and also a background behind that, which can wipe away trackers. This can be dangerous, and here this is nice, but maybe this is blowing in the wind. But we have these houses here in the back. Normally, I don't like to track stuff which is far away, because you remember, we have a full HD plate here, which is not so big, 2K here. And this is far away, which means through the pixel matrix, a feature which is here tracked jumps between pixel positions. And this can inject, will inject error. But in our case, we need that here, because if we don't track something on these houses, we don't have too much representation here of height. Then we only have these areas here and the trees, which are also dangerous. So we need the houses here. So this is a kind of way I look into a shot before I start. I now get rid here of my annotations. We talk about these in a moment. And now we can take a look into the idea of detecting features and this semi-automatic approach. What does it mean? Under this marker menu here, we have detect features. And the moment you click that, Blender places now in the frame where you are a bunch of trackers. But the settings for these trackers are the settings which you define here. So this is normally the first step you do. You go into your tracking settings and you make sure that you get the right tracking settings for the features which you are now detecting. And if you don't know what these tracking settings are here, we have a full lesson about that. I think it was named Advanced Tracking Settings, and there I explain everything which is that here. So I go through that now and I say I want to have here a fine, I want to have normalizing going on, and I want to have a high correlation. So I really want to have sure patterns, let's say 90%. Now these are set, and if we now go here to the first frame, we have done that, detect features, we get now our features here placed. In opposite to other solutions like for example Synthesize or even Fusion's or Nuke's tracking system, these trackers are only placed in a frame. They are not replaced if you are tracking forward and a tracker is lost and disabled. This system doesn't replace them automatically. So this is only a placement help for you. And if you need more trackers in a later frame, you have to do the same thing again. So detect features and so on. So now we can start tracking, but before we do that, I want to talk about how these elements are placed, because we learned how to place our minimum 8 trackers so that you get the best result. And maybe you now see that these placements are not good. We have too many trackers, for example, on the floor, but nothing in the Z direction and so on. So what you can do is you can go into the last operation menu, which is here. If you don't see it anymore, you have done something else, go back and add your trackers again and then go into this HUD here. First things first, the placement. Normally Blender places these trackers here over the whole frame. But what you also can do is we can place them inside of annotation nodes. And this is something, like I've said, I use in practice a lot. So for example, I need a point cloud for the floor. I have tracked my shot before, so everything is done. But now I need a whole bunch of trackers which help me in 3D viewport. What you can do is you can take your annotation tool. I hold down the D key on my keyboard and then you draw here an area, for example, on the floor, something like that. and then you say detect features. But before you do that, you go into your tracking settings, because I want, for example, now place 0 weight trackers. We talked about these as helper trackers in one of our first 3D tracking lessons. And here's the weight. So you can say, yeah, these are trackers, but I don't want that they have any weight. And if you now do detect features and say here, only inside this area, then these are 0 weight trackers. Then you can retract the scene, resolve the scene, and your result will not change because they don't contribute to your solve. That's the workflow I use here. So the takeaway of that now is you can also use the system here. Let's go back here and set the weight back to 1. Otherwise you don't get a solve, so don't forget that. Our new trackers need a weight of 1 here. So if you now want to detect features, you can say inside of an annotated area or outside of an annotated area. This is also a good thing like masking. You say, I don't want to have trackers here on the sky, or I need trackers here on the floor. Then you can draw with the press down D key. This is the annotation tool, which is here. So if you don't know the keyboard shortcut, here are the tools and you can do that here. Okay, let's go back to the whole frame and get rid here of our annotation. Okay. What you also can do, let's go back here and do the whole thing again to show the rest. The next thing is the margin here. And the margin means how close can these trackers be at the border of the frame, because they are really likely lost if the camera moves. So if you increase the margin here, you see Blender holds a margin here to these areas here. So this can be a helper if you like something like that, but you can't say on which side. So I stay with 16 and I delete then short-living trackers then behind later. The threshold is an important one because here you can tell the system how good the contrast has to be for a tracker, and I want to be on the safe side. So I increase the threshold, or better to say I decrease the threshold here to let's try 0.2. And now you see it's going into the wrong direction for me. So let's go to 0.8. I want to have less trackers. Now these trackers seem to be more sure that they hold. Let's increase that only to test it. 2. Now you see the higher this threshold here, which doesn't make too much sense from the name, I think, the better the contrast has to be. But now comes the question, okay, but now you have less trackers. What if I want to have a high contrast threshold here, but I don't get enough trackers? How to increase the amount of trackers? And for this, we can use the distance. Because many trackers in a clump doesn't contribute much to the solve later. So it's much better to have an equal spaced point cloud for the tracking. And this is the job of the distance. So here 2 trackers have to hold the distance to the neighbors. And if you then decrease that, you maybe get more trackers, which are still inside of this threshold. So the more sure idea, but you get more of them. So that's the way you increase the amount of trackers. Okay, now let's talk about these trackers here. You will see that these trackers are now placed by contrast. And what you now can do to have housekeeping done is you can now go through the plate and say, yeah, I don't want to have, for example, a tracker here and don't want to have it here. You can select them here. And like always, we can go here to the track menu and see this guy here, what it is seeing. And so we can prevent things like, for example, that here. I'm not sure what Blender thinks here, but I see here that Blender likes here the edge of this thing in the foreground and the shadow on the background, which are not a static point. It's a crossing of edges of objects in different distances, and this is always bad. So I would go in here and kill that here before we later have the problem. So go through here. Now it's a good time to do that and try to find these bad guys. Here's also something. we have here a crossing line between this stone here and the tree. This will slide a lot, so kill that. 2 lines in different distances, same like this one here. That's the downside of using this automatic detection, because everything you learned before is now on stake. So you really have to make sure that you have a good solution for that. I don't do that now completely. You see, you could do that, but I want to show you later other tools to get rid of that. So let's select now all of these, A key, and now drag forward, which is Command T, or you can also use here the buttons on the bottom here. So do that. And now we have tracked all of these. And as I told you, let's home here, the view here. You will see that the tracks here are thinning out. We start with a whole bunch of tracks, and then more and more tracks are dying, or better to say they are disabled by the system here, and we get these zombies here, these red ones. One thing I normally do to analyze that now a little bit better is I press Alt-D, which change the disabled trackers to hide. You also can go here to clip display and say show disabled. It's the same like Alt-D, so this is a toggle to bring them in and out. And now you really see what's active in a frame, and we start here with a whole bunch of trackers, and the more we go here to the right, you see they are dying now out here. I think at the end we only have 2 trackers left. What we also have as an indicator for that is here our tracking dope sheet. We see 3 colors. We talked about these colors before. Gray means we have more than enough trackers to solve that. The solver thinks that. Then we have here the green area, which means, okay, we have quite enough to do that. You remember, good placed 8 trackers are enough for the solver. And the red one means we don't have enough trackers to do that. We only have 2 trackers. So this is something which we now can use to say, okay, at the end we have not enough trackers. So what do we do now? What I do here is first, I make sure that I don't retrack the tracks which are tracked. So Alt-D again to get all the trackers back, also the disabled. I select them all by pressing the A key twice. You see, if you press it here, you now have all the trackers here. Alt-A disables everything, A enables here the selection for all. And then I press Ctrl-L for locking these guys. And you also see here now in the list that all these trackers are now locked here. Great. So I don't retract them. And now Alt-D again to get rid of all the zombies. Now I jump to the end of my plate here. These values are still valid, so detect the features. We go in here. Now I start again to get rid of everything which I don't want. So this is something which you have to do now here at home for yourself. I'm now lazy because I know that you can do it at home. So let's say, okay, that's okay. We want to use that. Press the A key. Only the unlocked are now selected. Great. And now Ctrl-Shift-T to track the whole thing backwards. Okay, now we have done this. And now Ctrl-L for locking them. Let's take a look here. Everything is gray. That means, okay, Blender is now thinking, okay, we have enough of tracking. But before you now press solve, I want to show you a little helper and a trick. If you look at a plate like this, you normally don't see the problems too fast. Yeah, you see, yeah, we have everything trackers. Now let's solve. Let's do the following thing here. Let's go to the clip display and deactivate the footage. You also can use the keyboard shortcut M like mute here. This is also a toggle. Let's look into the world of the solver. You remember we talked about the solver and how he sees the world in our first 3D solving tracking lesson. And you now see, okay, scrub through that. We have a lot of trackers here at the beginning. Everywhere in this frame are trackers and they are moving all in directions. That's nice. And now we see that more and more trackers are dying out. And the thing is that around, let's say, frame 80 or so, between 80 and 90. You now see a problem. You see, we still have enough trackers here. We have more than 8, but if you now see the placement, you see that they are all here on the houses and only some here. And this is one axis. We don't have trackers here left and so on, or here. So this means I think the solver will lose here its parallax. This is something you have to keep in mind. We want to have a nice equal computation of trackers in your scene. And here in this area, we don't have enough of these. So let's go to frame 90. I unmute our footage and we do detect features once again. Everything else should be locked, I think, yeah. So detect the features again. Now we have here trackers in the areas which I like. And like I've said, if you don't get the trackers at the positions where you like them, because you say, I need here on the floor and the house here, use your annotation tool and do this detect features inside and outside the annotation. Do it twice if you need, so you get your tracker in areas where you really need them. And now we track them forward. I go back to frame 90 and track them backward. Okay, now Control L them again. And now we have really a whole bunch of trackers. Press the M key and take a look now. Now I think we have enough parallax going on here also in these frames here. Okay, now we have a really big bunch of trackers. Let's analyze how many trackers we have. If you go now here over the dope sheet, Control spacebar, and we look here into the list, we can sort by name here and scroll here through. You see we have tracker 253 trackers, which is a whole bunch of trackers. So the solver will later need more time to solve the whole thing. And so I don't solve directly. I now go in here and I want to kill what I don't like. So what do we don't like? One thing would be, we can sort here, for example, for how long a tracker lives. So sort for that. And now we go here to the top, or you can invert it. And now all the trackers are sorted here by their state of living. And we see here, we have a tracker here, 182, which lives for nothing. So this is a tracker which doesn't make too much sense. Here, 1 frame, and then it's killed again. Here are some trackers, let's take a look here, which only live for 2 frames. And these are results which doesn't make any sense, because from this information, we can't get a parallax and the solver can't do anything with that. So this is a thing we can get rid now. So how to get rid? One thing would be make a list here, go in here, select them here, and press then the X key on your keyboard here over the plate and kill them. But we also can go in here and make this automatic. And for this we go to solve. We later go again into this area. And here's a cleanup area. Now I have to select all the trackers again and I want to unlock them. Let's show the zombies again, show disabled. I select all of them and you see now they all should be selected. I Alt L them again to unlock all of them. And if it doesn't work, sometimes you forget some. There's a little trick here. If you go here to the dope sheet, you see here this lock symbol. And you see now they are all unlocked. But if you have some left here, let's do that. What you can do is you can go over the first lock which you want to open, hold down your left mouse button, and then you drag with the pressed mouse button here over the locks. And so you open the locks here. So this is sometimes useful. Okay, now all trackers are open again. Now we can work with them. And what we now do is I go here to clean up, and now I can tell the system how long should a tracker live as a minimum. And I say we have enough trackers here. Let's say I want to have a minimum of, let's say, 10 frames. After doing that, make sure with Alt A that you haven't selected any tracker here, because the type, how we now filter the stuff and clean it, is at the moment select. So it only selects, but it doesn't delete them. But you can do that if you like, but I like select more, so I deselect everything. I go now here over clean track and I click now here, and now you see we have a whole bunch of trackers selected here. And these here are now all the trackers which live shorter than 10 frames. And if you now look into our list, you see exactly what we have seen before. Yeah, there are some trackers here. And now you can go in here and say with the X key goodbye, we don't need you anymore. So get rid of the stuff you don't want to see here in the solve, because it takes a long time to do that. Another thing which you later can do is we can later, after the solve, do the same thing here with this reprojection area, but we haven't solved it yet, so we have to do a little bit more work now here. The next thing you can do, like I've said before that, we have searched for all the trackers which track something which is not useful, sky, edges, foliage, reflections, and all of that. We removed all the shot trackers. As we go now into analyzing that here. So this here are the graphs of all our trackers. And the question is, what do we see here? These lines here, let's take one guy here as an example, this one here. And I can select this here by this button here. So if you selected something, normally you see everything here. But if you click here, this little arrow, you only see the tracker which you have selected, or the trackers, which helps you now to analyze that. This here is not the position curve. This here is the speed curve of our tracker. That means how fast the tracker moves. If you have a camera move, trackers which are close to each other should move really at the same speed. What's also not really often doing is that you have a sudden jump of a tracker. Okay, if you have a crash pan or the cameraman stumbled over something or so, yeah, it can be that suddenly all trackers are increasing their speed a lot in one frame. But normally you have a more smooth appearance. And what you can do now here is you can look through the graph here and say, hey, there's a tracker with a really big spike. What's going on here? I go here now with my time indicator in this area here. You see a mass here, and I now select the curve here. And if you select the curve, you see here the tracker 199, what it sees. There's motion blur going on. And to find it here, you can hover with your mouse over the plate and press the comma key on your numpad to zoom in. And if you do that, you see now this is the guy here. Now comes the question, what is this guy doing here? If you now scrub here around, I do this really often with the Alt key. So if you hold down Alt and scroll with your mouse wheel, you can do that here. You see that suddenly when it came here to the border, instead of disabling this tracker, it found something new, you see? And this will later destroy your solid solve. So in this manner here, you say, okay, until this point, maybe this was a solid track. What we do here is we cut everything to the right away. To do that, we learned that we have here these buttons, clear to the right, clear to the left, or you can use your keyboard shortcuts, Alt-T or Shift-Alt-T. And you see, this is also doing the job, but in my case, I shave it now here to this side. Okay, now it's gone. And that's the way to get rid of these spikes here. If you have a shot where you have really many trackers, sometimes it's absolutely okay to delete them. But if you have a shot where you don't have too many trackers, it's dangerous to delete too much. You see here, this tracker is hell. It's sliding here, the edge up and down. So this is something we don't need at all. If you have done your homework, like I've told you before, you went around and searched for all the trackers sitting on edges, this would not have happened, but it happened here. So let's take the next guy here and take a look where it sits. A window here. Doesn't seem that this here makes any sense. Let's take a look here. It was good for some time. You started here. If you want to look on the tracker, you remember the L key on your keyboard. And then if you now move around, you have a stabilized plate. And we can go here and we see it was quite a solid track until we came then to this point here where it suddenly jumped. So let's go to this point here, delete the right here, or what you also can do is if you have the problem, you can now go one frame to the side and disable the tracker. You remember disabling trackers, this is something we talked in a lesson about, is clicking here the eye symbol, but then it's only disabled if it's long enough for this frame. So you hold that here. So the question is, does it go back to the original one? No, it's really bad, so kill it. Okay, also this here is now homework. Now one question which you maybe have is, okay, I can get rid of the spikes, but what about this thing here? So you see here maybe a spike, or this here is a nice one. I take this one. So is this a spike? Let's take a look and analyze that. I told you that this here is a speed curve. And the question is, why does this track suddenly have a big speed here? I see here that's not the best example here because it was really a bad track. Let's take a look here. Okay. Kill it here. And maybe I find a better one. Let's try this here. It's now a little bit a gamble. Okay. It's not. Yeah, but I think I can explain it with that here. You really think that this here is a spike, but really often this is not a spike, it's at the beginning or the end. It can be, but it hasn't always, or it isn't always, because like I've said, if a tracker is injected into the system, it directly starts to move, and this is then seen as a spike. But if the spike is at the end of the line, so if it's now added here, and you see the spike at the end, which is not here, then really often it touched here the border and then it moved. So this is something you have then to remove. I hope this is clear, but if you analyze a little bit here now, your curves here, you will see exactly the problem. Okay, I think that's enough about these areas here. So let's make our first solve here. And for this, I go into the camera settings. I want to have a sensor size of 36. I don't know anything about the lens. Maybe I know, I think it was around, let's say, 35 millimeters or something like that. But we can try the Blender way. So we say we don't know anything about that. And then we can ask Blender for helping us. So let's go to the solve. Keyframes. Which keyframes do we use? You remember we analyzed the shot and we said, yeah, at the beginning we don't have a too good parallax. So what we can do here is we can try with 1 to 30. Let's try. But keep that in mind. We need 2 keyframes to have a good parallax. And now you see we have a solve error of 5 something. And we have a message that some of these things are not solvable at all. So they are bad. But we get a solve error, which means that something is going on here. Okay, that's not bad. But 5 is too much. You remember, we want to go under 1 here with that. Now we have more information. That's the reason why we want to solve. Let's go back to our cleanup and go back to the curves. You now see in the curves, I can deactivate here with this movie slate here, this thing, and switch it on. You see this blue line here, which pops up when I click that, is the average solve error, which you have here. And you remember we talked about that in one of the basic or fundamental lessons about solving, that this is how sure now the reprojection is. And you see, it looks really good. You don't have peaks here in this blue line, so the solve is really steady. Otherwise, I would look into the areas where we have more problems. But this looks really steady. Another thing which we now have as an information is that every tracker now has a solve error, or better to say a reprojection error. You remember, if you go here to clip display, we can go here to 3D markers and info. And now if you select something here, you see the average error. For example, this one has a really big error of 7 something. And if you are now on the hunt for bagged ones, what you can do now you have the information, is you can go here to your dope sheet and ask this time for the average error. We can sort the list, and you see now we have here the tracker 199, which has an average track error of 13, which means this is quite high. So where is this tracker? It's this one here. And I now can start analyzing this guy. It lives here. It works fine, but then here suddenly we have this chaotic spikes going on. This is an indicator that we have lost here contact maybe. Now you see this can be a problem, but in our case it's really the camera shaking here. So it's really not sure, because this here is not a good result for him. What you now can do is you can analyze these guys here and try to get rid of them. To do that automatically, we can go back to our cleanup now here. And beside of the number of frames which we used, we can now use also this error, which is the reprojection error. So let's say we have a solve error of 5. We have some trackers which are really high. So let's go from the top. We say, let's go down to 8. Select 8. I deselect all my trackers here to really see everything, and Alt D, get back the zombies and also make sure that they are not selected. And then we go here with the tracker of 8 and say here clean track. Now you see they are all selected, and these are the most terrible trackers which have a tracker error higher than 8. We have enough, so kill them. We get rid of them. We have at the moment a solve error of 5.1. So what I do now is I press Shift S and solve everything again, or you can also solve the motion here. And now we see we have a little bit less solve error. This is one way of doing. Search for really bad trackers, try to get the solve error down. But before you do that now more, I want to show you something else. We talked about the process, how it starts, so that we have 2 keyframes which need the same trackers in both frames, a minimum of 8 and so on. We use frame 1 to 30. So what if we say we change them? You also see here the keyframes. So let's look around here. Do we have frames where we have more parallax going on and we still have the same trackers? Because here we don't have much parallax. So between 1 and 30, you see it's only a nice shift to the right, but not really much parallax. Let's say we search. This is now an experiment, which you can do at home. We have here, okay, if I go to 170 here, for example, let's say this is the second one. We have here some trackers. Are they still there when we go to the back? And now we have much movement, and I hope I have enough parallax going on. Now we go to the other side. Nice, nice, nice. And these trackers are still there. So let's try 40 here. These are the rules which we learned for the keyframes. We want to have the same trackers in both keyframes. We need the parallax for them, and maybe this helps. So solve error of 4.18. Solve that again. And now we have a much higher solve error. And this is something for people where we say, oh, these keyframes are not good. Maybe. But maybe now Blender or the solver sees the scene better and sees now how bad its reprojection is. So let's ask him for better keyframes. Let's do that and try that. We get an even higher value. You see, our frames were not so bad, but I think I want to have here something else. Let's say 60 and try it again. And we now see that this here really is sometimes something where you really have to analyze your shot. You really try to find good keyframes here, and you see now we are back in an area where we say, yeah, maybe that's better. Let's try more. Like I've said, this is a fast tutorial. Normally you have more time here to do that. So let's go down with the arrow to 6. Bring all the zombies back. Make sure that everything is deselected. Clean the tracks. Kill these and solve again. Solve errors better. Okay, these were really bad tracks. And what we now also can do is we can talk about the focal length. Maybe we have many trackers going here to the borders of the plate, and you remember this will then change if we have the focal length, and we also have then, if we have a really low focal length, strong radial distortion. So let's try to find a focal length here. At the moment it's at 24. Let's try finding a focal length. We have a solve which is okay-ish. Try it. And now you see the focal length here has changed, and suddenly the solve error has changed. You see, our focal length was really bad. It was not so accurate, and this was the problem also here. If you have many trackers which are in this depth here, you remember, if you have a wider lens, you widen the space. If you have a tighter lens, yeah, you bring it together. This really changes also where the trackers are. This can make a problem, like you see here. So we have a solve error of 0.5, but we are not at the end at the moment. If we have now something like that, and we found now a better solution here, what we also can try, let's get rid here of the focal length. We have it, and I think it was really 35, so we are not so bad here. We can now ask for the lens distortion. So let's ask for the lens distortion. At the moment we are 0, 0. Ask for this, and we have a solve error of 0.5. And you see it has even a better solution. So that's the way I normally go in here. Like I've said, we have not really sorted out all the problematic trackers. I think we can get a much better result here. I think the keyframes are okay-ish. We have a focal length which is better. We have the lens distortion made. But now at the end we really want to test if this is somehow good. And like I've said, if sometimes the solve error goes up, it doesn't mean that your solve is now worse. Sometimes now the solver sees the scene and suddenly understands the scenes better and say, okay, if this really is the scene, then the reprojection of this point, this point, this point is not so good. It's an iterative process. It's not a one-click solution, in no tracking solution. But now let's test the whole thing. I go now into a frame where I see my floor, which I want to have, let's say here. And then we go here now into the scene setup. I select my 3 trackers, and remember the last tracker you select is then the tracker which is then the origin. Let's say we want to have this guy here. And we say then on the geometry, orientation, sorry. This is the floor. Then we have this here as the origin. So let's take this here as the x-axis. Here we go. We also can have a scale here between things. Let's say, I don't have any clue. So let's say these two here have a scale of 2 meters to each other. Okay. And now we can reconstruct the scene as a tracking scene. Let's take a look into that quite fast. I take here now this cube here, scale it down, place it in Z upwards, press the V key because I have drop on floor activated, so this helps me here. Then we take this plane, make this smaller, rotate around the Z axis, and what I now do is I go here to the wireframe with the Z key. zoom in a little bit and grab it, not in Z, to move it here on the floor. Rotate it around Z again. And let's go here to modeling and take this edge here and move it, for example, to the right. Move this edge here. And this edge here at the back in this direction. And you see, it's not so bad. It's not perfect. If you look here to the lines here, you see that the focal length is not complete. I think it was 35, but it's quite good for the not done work which we have done here. Like I've said, we have to sort a little bit more here, but it's not so bad here. So you see, that's the way you can try to solve a shot like this here. If you have done now all of that, what you can do, let's make here a new layout. Tap here, go into the camera, and now what we can do here is, I don't want to see, for example, here the plane like this. Let's go here, say wireframe, and then we can go here to view and say I want to have a viewport render animation. Now it renders that. And the thing is that I now want to see that later in my image viewer. So if here now the cube really holds and the plane holds, and then you have your ready-made solve. Okay, rendering is done. I go now to view animation. And now you see here in my animation viewer how the whole thing is stinging. Like I've said, it's not 100% here to the back here. I think the focal length is not 100% accurate. But if I see here now the cube, I see it really fits good. Also here the plane sticks quite well. So if you place here an object onto that and comp it with a little bit of motion blur and thing, I think it would hold the whole thing. If you want to make it better, you know now all the things you can do here, which you can improve. I hope this was useful. It was showing the semi-automatic tracking approach and also how to tackle a shot, how to find trackers which can make problems and how to get the solve error down. If you have questions about it, please write in the comments below. I'm really happy that you like this series so much. So see you in the next lesson. Your Helge Maus.